Today we will be going over solving polynomial inequalities. The first question says x squared minus 6x is less than negative 8. And the first step would be to move the negative 8 to the other side of the equation, so we have 0 on one side. So we have x squared minus 6x, and we're going to add 8 and less than 0. Then we're going to factor this, so we have x minus 4, x minus 2 is less than 0. And then afterwards, we have two ways that we can approach this problem. Well, we have multiple ways, but in this video, I'm going to discuss two different ways. So the first method is by splitting this up into further inequalities. So what I mean is that here, I'm just going to rewrite this again. So we have x minus 4, x minus 2 is less than 0. So basically, we have two parts. We have x minus 4, and then we have x minus 2. And when we multiply those two values, the number has to be less than 0, which means it has to be a negative number. And when we multiply two things and when we want a negative number, either the first value has to be positive and the second has to be negative, or it has to be switched and it has to be negative and then positive. So we can either have positive and negative, or we can have negative and positive. Because when we multiply these numbers, we will always get a negative number. Always get a negative number in the end. So we have two different cases. So we have either this case, or we can have this case. And so we're going to write this down. So I'm going to go over this part first. So we have x minus 4 is a positive number, so greater than 0, and x minus 2 is less than 0. So this has to be a positive number, and this has to be a negative number. That is scenario 1. Or second part, x minus 4 is less than 0 and x minus 2 is greater than 0. So we can either have positive and negative, or we can have negative and positive. So then we're going to solve these inequalities. So we get x is greater than 4 and x is less than 2, or x is less than 4 and x is greater than 2. Then we're going to simplify the inequalities on both sides. So on this side, we have x is greater than 4 and x is less than 2. You ask yourself, can a number be both greater than 4 and less than 2? And you say, no, that does not work. Because if you draw it on a number line, say this is 4 and this is 2, if a number is less than 2, oh sorry, this should be an open dot, and if this is greater than 4, a number can't be both on this side and on this side. So we realize that this inequality actually doesn't work. So we had either this or this. So if this works, then we have that as our answer. So x is less than 4 and x is greater than 2. And you ask yourself, does that work? Then you realize that it does. Because if you draw a number line, we have 2 and 4. If x is less than 4 and x is greater than 2, we just have this region between 2 and 4. So that's going to be our answer. Or we can write that as 2, 4. So this is our answer. Since this part didn't work, we could have had that or this, so as long as this works, so this would be our answer. So any number x that we plug into this equation between 2 and 4 will satisfy this inequality. And sorry, I keep saying equation, I mean inequality. Yes. Okay, so that was the first way of solving it. I'm going to copy this same problem and put it on here, and I'm going to do this in my second way of doing it. The second way of doing it is to find the roots and then and then draw a number line. So let's say we write this as x minus 4, x minus 2 is equal to 0. Then the roots are 4 and 2, right? So we're going to draw the number line. So we have 0, 1, 2, 3, 4, 5, 6. So we're going to indicate the roots on the graph by drawing circles. So we have 2 and 4. And the reason why I do an open circle is because it's a less than and it's not less than or equal to. So it's not including 2 and 4. And then what we're going to do is we're going to choose any number from this first region, which is basically any number less than 2, and then a number from the second region, any number between 2 and 4, and a number from the third region, any number greater than 4. And we're going to choose any number in each region, and we're going to plug that into this inequality right here, or we can plug it into this or this, it doesn't matter because they're all the same inequality. So we're going to plug it in to see if it satisfies the inequality. So here, let me start here. Let's say I can plug in negative 100, I can plug in negative 50, but I'm just going to plug in 0. Any number that's less than 2 would work. So let's say I'm going to plug in 0, okay? Then I'm going to plug it into this part. So we get 0 minus 4 times 0 minus 2 is less than 0. So we get negative 4 times negative 2, which is positive 8, is less than 0. But that doesn't work, so I'm just going to write no right here. And if you try plugging in 1, negative 50, you'll realize that all of those values don't work in this inequality, so it's basically no. Any number less than 2 does not work, so it's no. Then we're going to choose a number between 2 and 4, and I'm just going to choose 3. And so 3 minus 4 is negative 1, times 3 minus 2 is 1 is less than 0. So negative 1 is less than 0, and that does work, so we're going to write yes. Then we're going to choose a number greater than 4, and I'm just going to choose, I guess, 6. So 6 minus 4 is 2, times 6 minus 2 is 4 is less than 0. 8 is not less than 0, so this is no again. So we have no, yes, no, and the answer to this inequality is going to be the regions marked yes, and in this case we only have one region, any number between 2 and 4. So the answer is going to be x is greater than 2 and less than 4, because it marks this region right here. And draw the parentheses. And as you can see, this method, we get the same answer as the first method. So both methods work. And just to give you a better understanding of this second method that we're using here, so when we write no, yes, no, what we really mean is that, so assume this number line right here is the x-axis of a graph, okay? Okay, hold on, I'll just write this in a better color. X-axis, sorry, I don't know if you can really see the green, so. And so, let's say I draw the y-axis, and this should intersect this 0. Okay, so let's say I'm actually drawing this graph, and I draw this x-axis and the y-axis. And let's say I draw this graph of x squared minus 6x plus 8 equals y. Y equals this equation. Then we get a graph like this. We get a parabola, something like this. And the reason why we mark the roots is because that's where it intersects the x-axis. And as we can see, we want this graph to be less than 0. And the place where the graph is less than 0 is any region between 2 and 4, as you can see from this graph. So when we say yes, what we really mean is that this graph is under the x-axis, and we're just basically sort of plotting the numbers on the number line, which acts as the x-axis, but we're just not drawing the graph, if you see what I mean. Okay, moving on. So we have 2x minus 3 times x plus 1 is greater than 0. And since this is already factorized for us, we don't really have to do anything. And so I'm going to use method number 1, where we make more inequalities. So when we say this times this, so this part times this part is greater than 0, it has to be a positive number. In order for this to be a positive number, 2x minus 3 can be positive, and x plus 1 has to be positive, or they can both be negative. So I'm going to write these scenarios down. So let's say the positive scenario. 2x minus 3 has to be greater than 0, and x plus 1 has to be greater than 0. Either that, or we can have both of them negative. So you can have 2x minus 3 is less than 0, and x plus 1 is less than 0. Then we're just going to solve this. So 2x is greater than 3, x is greater than 3 over 2, and x is greater than negative 1. Or we have 2x is, so this should be x is less than 3 over 2, and x is less than negative 1. We're just going to simplify both of the inequalities on both sides. So when we say x is greater than 1.5 and x is greater than negative 1, basically we can just say that x is greater than 3 over 2, right? If we draw the inequality, we can see this better, or draw the number line. So this should be negative 1. That's negative 0, 1, 2. So if we graph x is greater than 3 over 2, and then if we have x is greater than negative 1, the place where the graphs intersect is this region right here, right? So we can basically say that x is greater than 3 over 2. And similarly on this side, when we say x is less than 3 over 2 and x is less than negative 1, we can just say x is less than negative 1, because as long as a number is less than negative 1, it'll satisfy both these two inequalities. So we end up with this and this. So we can write that as x is less than negative 1, or x is greater than 3 over 2. Sorry, I switched the order, but yeah. So we can say this is this or this. And we can write that another way. We can just write this as negative infinity comma negative 1, and we can write this union, this u, which basically means or, 3 over 2 comma infinity. So either way is the answer. Okay, moving on to the next question. So x squared is greater than or equal to 5x minus 6. So I'm going to move this to one side. So x squared minus 5x plus 6 is greater than or equal to 0. Then I'm going to factor it. So x minus 3 times x minus 2 is greater than or equal to 0. Then I'm going to do the number line method. So, the roots, 2 and 3. So we have 0, 1, 2, 3, 4, 5. And then I'm going to draw the roots. So 2, and I'm going to color the dots in this time, remember. 2 and 3. Then I'm going to choose any number from any region. So let's say I choose 0 first, okay? And plug in 0. I'm going to plug in 0 to this one. So 0 minus 3 is negative 3. Sorry, let me write that better. Negative 3 times 0 minus 2 is negative 2. So this should be 6. And is that greater than or equal to 0? Yes. So now I'm going to choose a number between 2 and 3, and my only option, or actually I don't have a lot of options, but the easiest number would probably be 2.5. And I actually don't have to, the good thing about using this factorized form is that I don't have to actually plug the number in and solve it. So let's say I'm going to choose 2.5, okay? And then I have x minus 3, x minus 2 is greater than or equal to 0. I just have to know if this is going to be positive and this is going to be positive or negative. So let's say I plug in 2.5 into this. I know it's going to be a negative number. It's going to be negative 0.5 times, if I plug in 2.5 there, 2.5 minus 2 is just positive, so I'm just going to write positive. And if we multiply a negative number and a positive number, we get a negative number. And a negative number is not greater than or equal to 0, so I'm going to write no here. And I guess you could have actually plugged in and solved this, but that would have taken a bit more time, so I'm just going to assume that that's going to be a negative number, or no, I'm not assuming, but I'm just going to write that that's going to be a negative number without actually solving it. Okay, and then I'm going to choose a number here. I'm going to choose, let's say I choose 4. I'm going to choose 4. So 4 minus 3 times 4 minus 2, which is 1 times 2 is greater than or equal to, so this is yes. So here we have a yes, no, yes region, and so we have to look at the yes regions, here and here, and we're going to write that out. So basically we have x is less than or equal to 2, or x is greater than or equal to 3. And we can also write that as negative infinity comma 2, and remember this is going to be a bracket. Oh, sorry, and if they're at a u, which stands for union, bracket 3 comma infinity. So that would be our answer. Okay, this is the last problem. It might be kind of hard. X cubed minus x squared minus 6x. So we're just going to follow the exact same methods. We're going to factor this first, and we can factor out x. So we have x squared minus x minus 6 is greater than or equal to 0, and then we can factor this part out further. So we have x minus 3, x plus 2 is greater than or equal to 0. So when you have 3 different roots, so the roots here, so x can be 0, x minus 3 is 0, so we have 3, and we have negative 2. So when we have 3 different roots, I would say that the easiest way is to do the second method, which is to draw the number line. So I'm going to draw the number line here. We have 0, negative 2, oh, sorry, should have, okay, negative 2, 0, 3. Okay, then I'm going to draw closed dots on each one of them. So after we mark these spots, we're going to do the exact same method. We're going to plug in numbers in this region, this region, this region, and this region. So let's say I'm going to choose negative 3 first. So you get negative 3, I'm just going to plug it into this part. Negative 3 times negative 6 times, so negative 3 plus 2 is negative 1. That equals positive 18. Oh, I'm sorry, negative 18. So does this satisfy, is this greater than or equal to 0? And then we find out that's no. Then I'm going to choose a value between negative 2 and 0, so I'm going to just choose negative 1. So we get negative 1 times negative 4 times positive 1. This equals 4, which is greater than or equal to 0, so I'm going to write yes. And we're going to keep doing that, so I'm going to just plug in 1. So 1 times negative 2 times 3, that is negative 6, and that is not greater than 0, so I'm going to write no. Then I'm going to choose 4. So 4 times 1 times 6 is 24, and that is greater than or equal to 0. So I'm going to write yes. Then I'm going to write inequalities out of these yes regions. So first we have negative 2 is less than or equal to x, which is less than or equal to 1. And then we also have x is greater than or equal to 3. And we can write this as negative 2, comma 0, and then a u, and then we can write 3, comma infinity. So that would be our answer. This would be our answer. Okay, thank you for watching.